Hey guys, welcome back. This is our third and final electricity video. I'd like to thank you guys for giving this math a good effort. I know it's a different learning environment, that's for sure. And just remember, you can always email me with your questions. Applied kids, a special shout out to you guys if you're attempting any of this, because your main focus this unit is the generation project, which is also posted this week. Okay, so you have a good 2 weeks for that. Anyhow, what I decided was to not give you the solutions for this because it would take a while and it's kind of redundant. I'm going to give you one big example here, but those are the solutions there for those of you that have attempted it. Okay, and what I'd really like you to do is hit pause in about 5 seconds, because this is a really good example of circuitry math for a series circuit. Okay, so if you can hit pause and try to figure out these questions. Okay, so these are the givens. It's a series circuit, which is really important. Okay, and with that, understanding these three laws here are perfect for a series circuit. Okay, so your current is the same everywhere. So if you find current anywhere, it's the same everywhere at each resistor. Your total voltage is added up at each resistor, and your total current, your total resistance is also added up at each resistor. Okay, so that's crucial information to help you do this. Now it's time to hit pause and do it. Welcome back if you hit pause. So our first question is to find the total resistance. Okay, and again, if you looked at the cheat sheet, you would know that if you can find the resistance anywhere, if you can, to find the total resistance, you have to actually add up the three individual resistances. Okay, 3, 5, and 4. Got it? And that gives us 12 ohms. So that's the answer to A. B is total current. Okay, so total current, we're going to actually go back to Ohm's law. Okay, because now we actually know our total resistance. What was it? 12 ohms. Okay, so keep that in mind. We have a total voltage here and 12 ohms there. Okay, and if we go back to our triangle, resistance, voltage, and current, we know that current covered up is voltage divided by resistance. Okay, we have a total voltage of 24. We have a total current of 12. 24 divided by 12 is 2 amps. Okay, so that's how we would do B. C. What are we after in C? The current at each resistor. Okay, so this again, this is the easy one I was thinking about earlier. If we know our total current is 2 amps, based on the law of series circuit, we know it also has to be 2 amps there, 2 amps there, and 2 amps there. Okay, so that's a pretty straightforward one to do. For D, we want the voltage at each resistor. Okay, that's an Ohm's law question. So back to our triangle. Where resistance, voltage, and current, and we're looking for voltage at each one, so it's going to be resistance times current at each one. Okay, so maybe we'll just kind of throw it in here. Okay, so resistance times current, so we've got 3 times 2 for this one, right? 6 volts. We've got 5 times 2 here, 10 volts, and we got 4 times 2 there, 8 volts. I hope I didn't skip too many steps for you guys there. Okay. Finally, for power, we definitely have to go back to our cheat sheet and find some sort of equation that helps us figure out total power when we know things like voltage and current. Okay. Because power is voltage times current. And for the whole system, we go with our totals. Okay, so 24 times 2. 24 volts times 2 amps is 48 watts. Can you zoom in on me? So I hope that helps. Again, practice helps you get more perfect at this sort of thing. And that'll be it. Next up will be your project, which is way more qualitative, where you guys will be researching different ways we make electricity and creating a bit of a presentation for that. Thanks, guys.